Acid and bases reaction uh, is very common reaction. It's considered also a realization and neutralization reaction. So we will practice with some example about this type of reaction. First of all, we will practice how to figure out the Pronotion acid and bases. In general, what do we have? We have, for example, chemical B plus HA. They will react to give HB plus A minus. Which one is acid? Which one is base? Which one conjugate acid? Which one conjugate base? You have to keep in your mind, according to Pronotion definition, the chemical or the species that can donate, give H plus proton, that one will consider acid. And the one that accept H positive will consider base. So that's what you're gonna look for. Which one will give, which one accept the H plus, and you will decide which one is acid, which one base. So here, B, we will compare it before and after the reaction. Compare before and after reaction. B was, go to HB, that's mean accept, so B will be base. HA want to give A, so it's give, donate H, so it will be acid. Now in the other side, it's also we have acid and base, but we call it conjugate. We call it conjugated acid and conjugated base. So we decide also the same things, but the reverse. You will go opposite. So you'll compare HB with B. HB give a proton. So this one will be conjugate acid. A with the HA. So except, so this one will be a conjugate base. And it is confusing also for conjugate acid and conjugate base. It is the opposite to what's happened to the normal acid and base. So here acid will give you base, but we call it conjugate base. The base will give the acid, what we call it conjugate acid. So that's how you will decide acid base, conjugate acid, conjugate base according to Pronotion definition. Let's look at this two examples quickly here. Let's say HCl plus H2O give us H3O positive plus Cl negative. Which one is acid? Which one is base? Compare HCl with the Cl negative, H2O with the H3O positive. Here, HCl give H positive, give a proton. Don't forget the H positive, we call it the proton. And that will represent the same as hydronium, H3O positive, which is hydronium. It is the same because H positive will react with the water. Always in water, these type of reactions. So it will give you H3O positive. Anyway, let's go back here. H to Cl, HCl to Cl negative, so it's give. So this is the acid. H2O except your proton, so H2O here the base. Now the opposite when you will compare H3O positive with H2O, so H3O positive give a proton. As I said, here, when you are working with the conjugate acid and base in the product, you will compare it in the opposite direction. Okay, this type of reaction, you can see there are two directions for the error. That means it's reversible reaction, can go back and forth. We will talk about it in equilibrium chapter. Okay, so H3O positive here will be the conjugate acid, and Cr negative will accept the proton, so it will be the conjugate base. One more example for this definition. Let's say NH3 plus H2O, we will get NH4 positive plus OH negative. Compare NH3 with the NH4, H2O, and OH negative. NH3 accepts, so it will be base. H2O, OH minus give the proton, so it will be acid here. NH4 conjugate acid, OH negative conjugate base. Okay, see here some other example. Okay, titration. Let's practice with the titration calculation. When you titrate acid and base, we can do calculation to figure out the concentration of a node. So let's say we have here in this reaction HCl plus NaOH will give us NaCl plus H2O. Look at this equation. How many milliliter we need of 0.1 molar, 0.1 molar NaOH to titrate 250 milliliter or 0.2 molar HCl. Okay, so let's look here. So what do we have? We have how many milliliter we need of 0.1 molar NaOH to titrate 250 milliliter of 0.2 HCl. Don't forget here, molarity equal mole divided by volume in liter. Or sometimes also we can maybe we need this relationship, mole equal mass divided by molar mass. Okay, here, what we need? We need mole HCl to mole NaOH, mole to mole ratio. Okay, so here mole to mole ratio. We need to reach here. This one can reach it from molarity times the volume for HCl. That times the volume in liter, we will get the mole of HCl. Then We will use the mole-to-mole ratio to calculate the mole of vinegar. Here they are asking for volume, milliliter. So here, volume, molecular what? Molecular mole, which you will get it here, divided by molarity, which you already have it here. Okay, let's do it here. Volume, molarity HCl is 0.2 molar HCl times volume HCl in liter will be 0.25 liter. Now the mole-to-mole ratio between NaOH and HCl, don't forget this is mole. The molarity, it is mole divided by liter, cancel liter with liter. Here, mole-to-mole ratio between HCl and NaOH, it is 1 to 1. 1 more HCl, 1 more NaOH. Cancel mole HCl with mole HCl. Now I have a mole of NaOH here in the top, so you will divide it by mole. Sorry, this is mole divided by molarity to get the volume. This is the molarity of NaOH, so it will be 0.1 mole divided by liter NaOH. Get some mole NaOH with this one and do the math. And here we will get 0.2 times 0.25 and divided by 0.01, we will get 0.5. Sorry, 0.2, 5, 0.1, 0.5. So you will get 0.5 liter. So be careful, guys. This is 0.5 liter. They are asking for milliliter, so it will be 500 milliliter. So we need 500 milliliter to titrate the HCl. Okay, let's practice with another example for titration. Okay, now let's say we have this reaction. We have KOH plus H2SO4 give us K2SO4 plus H2O here F2 and 2F2O. Okay, now it's common. Okay, let's say what is the molarity of KOH of, let's say of 100 milliliter KOH was required to titrate 50 milliliter 0.5 molar H2SO4. So it's going to be the molarity. Okay, don't forget, mole, we need to reach the mole-to-mole ratio between H2SO4 and KOH. Okay, so here we have volume and molarity for H2SO4. So it will be in liter, 0.05 liter, don't forget that, times 0.5 mole H2SO4 divided by this one, sorry, the molarity, it is the mole per liter. Don't forget the molarity. Okay, now cancel liter with liter times right now the mole to mole ratio. Be careful here. The mole to mole ratio between KOH and H2SO4 is not 1:1. So it is 1 mole H2SO4, 2 mole KOH. Okay, now we have the mole. They are asking for molarity. Molarity equal mole divided by the volume in liter. So here we don't have the mole times 1 divided by the volume of KOH in liter. It is 0.1 liter. Now, let's do the math. Because we will have, 0.05. So it will be 0.05 times 0.5 and times 2 divided by 0.1 and will equal 0.5. Guys, just double check the number if I did a mistake here because I'm doing the calculation quickly. So it will be 0.5, let's do it here, 0.5 mole divided by liter, which is equal 0.5 mole. Okay, that's some question for the titration. Now let's go to other type of a question, which is the concentration, finding concentration of H plus or pH or OH minus or pH. Okay, let's put these things in front of us when you are practicing with the these type of question. Look at here. Concentration of H positive times the concentration of OH negative will equal 1 times 10 to negative 14. What else? pH will equal minus logarithm the concentration of H positive. Concentration of H positive will equal 10 to negative the pH. pOH will equal minus logarithm the concentration of OH negative. If we need the OH negative concentration will be 10 to negative pOH. What else we have? The pH plus pOH equal 14. Okay, now let's look to this example. Okay. What is the concentration of hydroxyl ion, which is OH negative, in a solution and has H positive hydrogen. By the way, hydronium, it is the same. So here, instead of H positive, we can use the H3O positive. The same thing, all of these. So don't let these confuse you guys. Instead of H positive, we can use the H3O positive. It is the same. Okay, let's go back. H positive equal 1 times 10 to power negative 6. Okay, so here they are asking for OH negative. We have the H positive, so we will use this equation. The H positive times OH negative will give you 1 times 10 to power negative 14. Now the OH negative will equal 1 times 10 to negative 14 divided by the concentration of H positive. And that's 10 to negative 14 divided by 1 times 10 to negative 6 here. Well, it doesn't matter. And this will give you 6 positive here, will give you 1 times 10 to negative 8. So the concentration of OH negative will be 1 times 10 to negative 8 molar. Here is molar. Okay, let's practice with another example here. What is the pH of a solution has OH negative concentration equal 1 times 10 to negative 4. So here we need to find the pH. The pH equal what? Minus logarithm the concentration of H positive. If we have the concentration of H positive, we can, or we will be able to calculate the pH. By the way, these type of question usually you have more than one way to calculate it, and it's up to you. Now let's try to figure out the concentration of H positive. So here H positive will equal what? Equal 1 times 10 to negative 14 divided by the concentration of OH negative. We are using this equation, guys. So here the H positive will be 10 to negative 14 divided by OH negative, here 10 to negative 4. That will give us 10 to negative 10. Now the pH will equal minus logarithm the concentration of H positive. That's mean minus logarithm the concentration of 10 to negative 10. Guys, try to practice with the log in your calculator before the exam and to be able to know how to use it. Because sometimes it's a little bit confusing for students if they didn't practice before with the log. So here, what you're gonna do, so you will have the 10 raised to power, okay. So we will have minus logarithm and it will be 2. So here will be minus logarithm, the 10 to negative 10 will be negative 10, and times the negative. So the pH here will be 10. pH will equal 10. Try to practice with it to find the pH, what it's going to be. Okay? There is another way, guys. Here, you can answer this question also. Look at here. We have the concentration of OH negative. So we can calculate the POH, which is this one. So it will be minus logarithm the 10 to negative 4. And that will give you negative 4 here. So it will give you positive 4. Then we will use this equation. pH plus POH equal 14. And we will say pH here will equal 14 minus 4. The pH will equal 14 minus the POH, which is the 4, that will give us pH equal 10. As I said, there is more than one way usually to calculate these type of calculation. Okay, now let's practice with some other example. Okay, let's keep these here. Okay, as I said, it's better to keep it when you are practicing or doing these questions. You know which equation, which formula you will use. Okay, so okay, what do you have here? Let's say calculate the concentration of OH negative of a solution has a pH equal 3. Now we need to find the concentration of OH negative. So what you're going to do here, first of all, we will calculate the concentration of H positive. Concentration of H positive will equal 10 to negative the pH, and that's mean 10 to negative the 3, and that will give you 1 times 10 to negative 3. Now I have the OH positive, but they are asking for the OH, so I will use this formula. OH negative will equal 1 times 10 to negative 14 divided by the concentration of H positive. That will give me 1 times 10 to negative 14 divided by 1 times 10 to negative 3, and that will give me 1 times 10 to negative 11. It is the concentration of OH negative here. Okay, now let's practice with this example here. Calculate say concentration of OH, calculate concentration of H positive, sorry. So a solution has pH equal, sorry, has a pOH equal 4, or less than 5. Okay, we know the H positive equal minus, 10 to power negative pH. But here I have pOH. So what are you going to do? You can use this formula. So here the pH will equal 14 minus pOH. And that will give us 14 minus 5, and that will equal 9. So here the pH equal 9. So H positive will equal 10 to negative 9. That will be 1 times 10 to negative 9 is the concentration of H positive. That's how we will deal with these type of calculation for acid-bases reaction calculation or example.